Welcome to G Fun Facts Online. Today we are opening a new front in the most dangerous war humanity has ever fought, the war against superbugs. For the last 80 years, we have been playing a game of scorched earth. We blast bacteria with broad-spectrum antibiotics, chemical nukes that destroy everything in their path. But the enemy has evolved. They have built thicker walls. They have developed pumps to eject our poisons. They have learned to sleep through the attack. We are running out of weapons. But recently, scientists have found a new target. It is not DNA. It is not protein, it is sugar. This isn't about cutting sugar from your diet to starve a cold. This is about glycobiology, the complex alien world of sugar structures that coat every living cell. For bacteria, sugar is their armor. It is their camouflage. And it is about to become their fatal weakness. In this episode, we are going to deep dive into the microscopic battlefield, where sugar molecules determine life and death. We will look at how Australian researchers cracked the code of an alien sugar called sutaminic acid, how artificial sweeteners might be our next great weapon, and how feeding glucose to a sleeping bacteria might just be the trick to killing it. Let's start with the battlefield itself. To understand why this new approach is revolutionary, you have to understand what we are actually shooting at. When we think of a bacterium, we often imagine a simple blob. But if you look at a superbug, like MRSA or E. coli, under an electron microscope, you realize it is a fortress. And that fortress is built of sugar. Specifically, bacteria rely on a massive mesh-like molecule called peptidoglycan. Think of this as the steel beams of a skyscraper. It surrounds the bacterial cell membrane and prevents it from bursting under pressure. For decades, penicillin and its descendants have attacked the enzymes that build this mesh. We were sabotaging the construction workers. But the bacteria got smart. They changed the locks, they modified the enzymes, the drugs stopped working. So the new science of sugar targets says, forget the workers, let's target the bricks. But it gets more complex. The really bad guys of the bacterial world, the gram-negative bacteria, like Pseudomonas aeruginosa, wear a second suit of armor called lipopolysaccharide, or LPS. This is a dense forest of sugar chains that acts like a force field. It is the reason why a drug that kills staph infection bounces right off E. coli. And on top of that, many superbugs wrap themselves in a slimy capsule, a literal invisibility cloak made of polysaccharides that prevents our white blood cells from even grabbing them. This is the glycom, the sugar armor, and for a long time it was impenetrable. Until early 2026. That is when a team of Australian researchers published a study in Nature Chemical Biology that changed the game. They discovered a way to target a specific, alien sugar called sutaminic acid. Now this is important. Your body is full of sugars like sialic acid. Bacteria know this. They usually cover themselves in sugars that look like yours, so your immune system thinks, oh, that's just a liver cell, leave it alone. But sutaminic acid is different. It is a bacterial-only sugar. It does not exist in humans. It is found on the flagella, the tails that bacteria use to swim, and the pili, the hooks they use to grab your tissues. It acts as a disguise, a don't eat me signal. The researchers managed to synthesize this sugar in a lab, which is incredibly difficult, and used it to create pan-specific antibodies. Think of these not as drugs, but as laser designators. These antibodies are injected into the bloodstream. They ignore every human cell, but the moment they see sutaminic acid, they lock on. They clamp down on the bacteria's tail. And suddenly, the bacteria is lit up like a Christmas tree for the immune system. In mouse models, this therapy completely cleared multi-drug resistant infections that were previously untreatable. This is called glyco-immunotherapy. We aren't poisoning the bug, we are tearing off its disguise. But what if we want to poison them? Well, bacteria are smart, but they are also hungry. To survive, they need iron. But the human body is stingy. We lock our iron inside hemoglobin. So bacteria send out little scavengers called siderophores to go find iron and bring it back through special gates. Scientists realized this is a supply line we can hijack. This is the Trojan horse strategy. There is a drug called cefiderocol. It is an antibiotic, but it has a fake siderophore tail. The bacteria sees it and thinks, oh look, delicious iron. It opens its gates, pumps the molecule past its own armor, and pulls it right into the heart of the city. Once inside, the Trojan horse releases the antibiotic, and the bacteria dies from the inside out. The newest version of this technology uses sugar conjugates. We link antibiotics to sugars like mannose or glucose. The bacteria is hungry for sugar, so it actively pumps the poison inside. It is a checkmate scenario. If the bacteria shuts down the pump to stop the drug, it starves. If it keeps the pump open to eat, it dies. It is brilliant because it uses their own survival mechanisms against them. But sometimes, you don't need to kill the enemy. You just need to make them let go. Infection is, at its core, an act of attachment. You cannot get a urinary tract infection if the bacteria cannot hold onto your bladder wall. They hold on using tiny hands called lectins, which are shaped to grab specific sugars on your cells. This leads us to anti-adhesion therapy. Imagine greasing a slide. If we flood the body with decoy sugars, the bacteria grab the decoys instead of your tissue. Their hands are full. They slip off the wall and are flushed out of the body in urine. The beauty of this is that it doesn't kill the bacteria, it just evicts them. Because you aren't killing them, you aren't creating evolutionary pressure for resistance. The bacteria survive, just not in you. A recent breakthrough involves synthetic sugars, called mannicides, that bind to bacterial lectins 1,000 times tighter than natural sugar. It is effectively a superglue trap for bacterial hands. Researchers at MIT even found a human protein called intelectin-2 that acts as a natural counterlectin, trapping bacteria in gut mucus so they can't cause infection. There is also a metabolic trick we are learning. One of the biggest reasons antibiotics fail is not resistance, but tolerance. The bacteria simply go to sleep. They shut down their metabolism. Since antibiotics target active machinery like wall building or protein synthesis, the drugs bounce right off. These are called persister cells. So how do you kill a sleeping enemy? You wake them up. You ring the dinner bell. Research shows that if you inject sugar, specifically glucose, mannitol, or fructose, along with the antibiotic, the bacteria sense the food. They wake up. They turn on their engines to eat. And in doing so, they inadvertently suck the antibiotic into the cell and activate the very machinery the drug destroys. It is called metabolic potentiation. We are literally sugaring the pill to trick them into suicide. In lab tests, adding mannitol made old antibiotics 1,000 times more effective against sleeping E. coli. And speaking of sweeteners, here is the strangest discovery of all. Saccharin, yes, the artificial sweetener in your diet soda. In April 2025, researchers found that saccharin actually inhibits the growth of superbugs like MRSA and Pseudomonas. It attacks an enzyme called carbonic anhydrase and weakens the cell wall. It turns out that while it is a treat for us, it is a toxin for them. Even better, it works in synergy with other drugs. It weakens the enemy shield so the main weapon can penetrate. Scientists are now looking at putting saccharin derivatives into wound dressings and hydrogels to treat infected burns. Who knew the key to fighting superbugs was in the diet aisle? Finally, we have to talk about the ultimate defense. Biofilms. This is the slime city. Bacteria excrete a matrix of DNA and sugar slime that hardens like concrete. Antibiotics cannot get through. 80% of chronic infections are biofilm-based. But we are finding enzymes that act as chisels. We can now deploy glycoside hydrolases that chew up the specific sugar chains holding the fortress together. We are also using sugars to deliver nitric oxide. Nitric oxide is a chemical fire alarm. When bacteria in a biofilm sense it, they panic and disperse, leaving the safety of the biofilm and becoming vulnerable targets. We are even designing vaccines that teach our immune system to recognize the unique sugars on the capsules of E. coli, aiming to stop sepsis before it even starts. This is the future of medicine. We are moving from blunt force trauma to precision warfare. We are manipulating the very code of life, the sugar code, to outsmart an enemy that has been winning for too long. From antibodies that target alien sugars to Trojan horses disguised as lunch, and from anti-adhesion grease to saccharin-laced bandages, the era of the sugar target has arrived. The next time you stir sugar into your tea, remember, that simple molecule is the key to the most sophisticated arms race on the planet. And for the first time in a long time, we might actually be winning. Thanks for listening to G Fun Facts Online.